Okay, we're going to look at another prototype problem. This will be a problem involving connected objects where the acceleration is known and the tension forces are unknown. And it is our tension forces that we want to find in this particular problem. We'll assume that there is no friction, that we're dealing with a frictionless surface. One of the first things I want to do is define my axes. So let's go ahead and draw the axes here. So we have our vertical axis, y, and our horizontal axis, x. Let's also define which object is object 1 and which object is object 2. So we'll call this one 1, and we'll call this object object 2. The first question we ask is, what are the forces acting on object 1, and can we draw those forces? Take a minute and go ahead and for yourself draw the forces associated with object 1. Alright, so let's look at that. Well, I draw object 1. We have, and I'm going to draw the box. Okay, we have the weight, force of gravity. Alright, we have a normal force. We have force of tension 2. And since we don't have a frictional force, there is no friction in there is no force in the other direction. Now, let's go ahead and draw the free body diagram associated with this particular object, object 1. So we're representing the object as simply a particle. We of course have our force of gravity and our normal force and the force of tension. Now, what is Newton's second law? Go ahead and write down Newton's second law, pause the video until you finish, and then start it again. Newton's second law is, of course, the net force is equal to the mass times the acceleration. And in this case, we know that there are forces acting in both the x and y direction. Next step you want to do is write Newton's laws in component form. Write Newton's second law for the x direction and for the y direction. Pause the video and take a minute to do that. Okay. We have that the net force in the x direction will be equal to Ft2, and that will be equal to mass times the acceleration in the x direction. For the y forces, sum of y forces will be equal to the normal force minus mg equal 0. Alright, now let's begin to consider object number 2. Go ahead and draw the forces acting on object 2. Pause the video and When you finish your drawing, start it again. Alright, so we're looking at object 2. And let's draw our box. Okay. We of course have force of tension 1. We have the back force of tension 2. We have mg equal to the force of gravity. And then we have our force, normal force. Now go ahead and draw your free body diagram for object 2. Pause the video, give yourself a chance to draw it. Okay, what is the free body diagram? We represent the object as a particle. We have force of tension 1, force of tension 2, force of gravity, and the normal force. Those are our forces acting on object 2. Now for object 2, go ahead and write down Newton's second law for the x-axis and for the y-axis. Okay, let's write down the Newton's second law for the x-axis and for the y-axis. So for the x-axis, sum of the forces in the x direction will be equal to force of tension 1 minus the force of tension 2, and that'll be equal to mass times the acceleration. For the y direction, we have the sum of the forces in the y direction equal to normal force minus the force of gravity. And that's equal to 0 since it's not moving in the vertical direction. Now we have an equation for object 1, an equation for object 2, both connecting the accelerations. Recall from object 1 we had this set of equations on the right. Object 2 we have this set of equations. So let's make sure we have it labeled appropriately. Object 1, object 2. Whoops, I'm sorry. That should be, let's delete it. This should be object 2 and object 1. Okay. Now notice that we have a connection between this equation for the x component and this equation. Both refer to the same acceleration. So we can use ft2 and substitute into ft2 here the mass times the acceleration. So I can write, we're going to come over here, and we're just going to substitute in here. So now I have that ft1 minus max equals max, and we find out that ft1 will be equal to 2max. Now if a is 5 meters per second squared, then ft1 is equal to 2 times 5 kilogram times 5 meter per second squared, or equal to 50 Newton. Likewise, now that we have ft1, we can obtain ft2. ft2 will be simply equal to MAX, and that's going to be equal to 5 times 5, which would be equal to 25 Newton. And now we have basically finished the problem. So that is end of problem. A couple points that I'd like to point out here is on this, particularly this first slide, in order to know what the tension is here, all right, we use Newton's third law, and whatever the force is at this point here from the tension in the rope is equal to the force here in the opposite direction on this object from the tension of the rope. Okay, we will stop there.